Today, G, it's 6G. Hello again, it's Martin North from Digital Finance Analytics, with the latest post covering finance and problem news with a distinctively Australian flavour and with a touch of philosophy on the side. Today I'm joined again by Salvatore Babones. Hello, Salvatore.
Hi, Martin. How are you?
I'm very good. How are you going?
Good. I'm going to be doing well much faster in the future, it seems.
Yeah, this is all about speed, isn't it? I mean, we've just been getting up to speed with 5G, and now they're talking about 6G. And I guess, is it just speed, or is it actually something even more interesting?
Well, it's speed and latency. Now, I'm a sociologist, not an electrical engineer, so let me give you the sociologist's explanation. Of course, we all want faster mobile communications. That simply means that how many megabits per second, or now we're getting into gigabits per second, can you stuff through the line? The goal for 6G is supposed to be up to something like 1,000 gigabits per second. Who knows if they'll actually get there? 5G, the target speed for 5G is something like 10 gigabits per second. People get much less on their actual phone. So the goal is for maximum speed of 1,000 gigabits per second for 6G, but with an actual experienced speed of at least 1 gigabit per second. So that'll be much faster than what we have now, obviously. But the other key item is what's called latency. Latency is the time it takes for something to happen. So you press the button, how long does it take before you get a response? And the problem with latency is that the longer it takes to get a response to something, the more that slows down anything you want to do in the cloud. Now, for most of us, that's not a problem. A tenth of a second of latency on our devices. Well, typically, if you're making a phone call, an audio phone call, there's a tenth of a second delay between what you say and when a person hears it on the other end. We don't really notice that. But of course, computers notice that. And in a tenth of a second, if you have a car being driven by artificial intelligence and a computer on board, well, a tenth of a second delay in getting information can be a life or death tenth of a second. So getting latency down has been the holy grail of mobile communications. 5G's biggest advantage over 4G isn't so much the speed, it's the low latency of 5G communications. But with 6G, the idea is to get an ultra low latency, something that would be virtually instantaneous. They're talking about less than 1 microsecond. That's 1 millionth of a second latency in the signal between you when you send a message, when you get it. And combining speed and low latency is going to open up new applications, which are really what I'd like to focus on.
Yeah, okay. And just to say that 6G is more than just an idea, isn't it? I mean, there are technology companies actively talking about this and actually doing work on it now.
Well, it's an idea plus, let's say. Samsung recently released a discussion paper about technical specifications for 6G. Now, the first half of the paper is all about the gee whiz things we'll be able to do with it. The second half is about exactly what kinds of technologies have to be developed in order to make it happen. The big problem from a technical standpoint that we see with 6G is that the available area of spectrum is in the, forgive me, this is technical language, the super duper high frequency. That is the terahertz range. So this is a band well above UHF. We're all familiar with VHF and UHF from our television days. Well, from UHF, ultra high frequency, you then go up to very high frequency, and eventually you end up into the terahertz world, which means, you tell me, Martin, how many beats per minute is a terahertz? It's a lot. And as a result, it has all the problems that go with that. So if you've ever tried to tune a UHF TV, you need line of sight. So if there's something blocking your way, you won't get a signal. It doesn't work that well on rainy days. So terahertz band won't carry a signal if there's a lot of water in the atmosphere. There's a high level of absorption, especially when it's wet, but in general. So there's not a lot of range for terahertz communications. This means that even more than 5G, 6G will have to be distributed, lots and lots of points on which people access it. And then that has additional implications for how the network will be designed. So if I just go into a little bit into that, into network design, because that'll have a lot of influence on what kind of applications are possible. It's expected that 6G will take the 5G evolution even further, whereas 5G has lots and lots of network routers located around a city. Instead of just having a big tower somewhere, there are routers on every telephone pole. 6G will take that even further. So the area covered by a particular 6G router will be very small. It'll be almost like your home network. These will be very localized. But there will be much more communication among those routers, so that with your, today with a 4G signal, if you're driving, there's a slow pass off from tower to tower, and you may lose your call or lose the call for a second as your call switches from tower A to tower B. With 6G, they're talking about building artificial intelligence into the system. So it will have to be a smart system that has you continuously on multiple routers. So you won't be on a tower and switch to another tower. You'll be continuously accessing the internet and accessing your mobile signal via multiple routers at the same time. And of course, the phone and the routers will have to have built-in artificial intelligence to try to coordinate this as a big Internet of Things exercise. And ultimately, getting to applications, 6G is about the Internet of Things.
And that's really, I think, where I'd like to focus, because obviously the technical stuff is still being worked out. But
Right.
the concept of being able to have very high availability, very high speed, and very, very low latency, which of course are the the eternal triangle of network design, suggests that there's a whole bunch of new things and enhanced things that can be done, and that takes us into a whole new area, doesn't it?
Well, the Samsung has a few, gee whiz sort of applications that they think are going to come along. Virtual reality becoming true, augmented reality turning into XR. We don't even know what it's going to be yet, but we find that very few people are using virtual reality these days. So will they use it more when it's available more? We don't know. They're talking about hologrammatic communication, and of course, that sounds very science fiction. The surgeon
Wasn't it on Star Wars years ago?
Yeah, it was in the original Star Wars in 1977. They said Princess Leia sent a hologram of herself. But again, although that might be very gee whiz for surgeons teaching surgery in the outback, it's probably not that practical for most of us. We probably don't need it. So Samsung was, I think, struggling to find applications. I prefer to think in terms of, not so much in terms of headline applications, but in terms of how it's going to change processes, how we think about things. So 6G the biggest thing it will do, it'll make distributed computing not only more possible, but more necessary. So far, mobile phone processing power has outstripped communications power. So the rate at which you're able to do calculations on your phone has risen faster than the rate at which the phone can communicate with the outside world. Now that we're reaching the physical limits of microchips and of microprocessors, and the physical limits of batteries, because remember, processing is the most energy intensive thing you do on your phone. As these two reach their limits, we expect more and more processing to be offloaded to the cloud. Now, of course, you can't do cloud processing if you have high latency, because every instruction sent to the cloud is going to take that millisecond, to get to the cloud and get back. And if you're trying to do anything complicated like video editing, it becomes impossible. I mean, those of you who've used Google Docs, of course, you can go on a Google Doc. That is processing in the cloud. You type a button and it goes to the cloud and comes back to you. Well, that's fine for text editing. Try video editing. If you go to YouTube's video editor, you essentially have to send a command, I'd like to trim this video. And then half an hour later, it gets back to you with the trimmed video, right? So you can't do video editing in the cloud currently. That's why we don't typically do video editing on the phone. These applications can't be done remotely. You need high processing power to do these things. Well, the expectation is with low latency and high throughput, but limited processing power, phones will rely on the cloud for processing. So we'll offload the processing from the phone to the cloud. And Samsung believes not to the cloud in the sense of some remote server farm, but to the cloud in the sense of the router itself. So we'll have routers with processors. Currently, routers are just essentially a dumb machine that sends a signal through, gets a signal back. It doesn't do much. They're very sophisticated, don't get me wrong, but they're not smart. Samsung expects that 6G will have much smarter routers where there will be excess processing capacity in the router itself. So that when I'm trying to do something on the phone that's very complicated, it'll use the processing in the router as an extension of my phone. Now, what will that enable? It's hard to say, right? We're talking roughly 10 years out into the future. We're talking about standards for the 2030s. But certainly we will, even if I don't know what they are, I expect there will be lots of new phone applications. Let's just say mobile applications. Let's forget that it's a phone anymore. Lots of mobile applications that will use they'll be very processing intensive. But the handheld device won't be able to do the processing. In the 5G world, I'm still stuck. In the 6G world, I can now offload the processing to the cloud in a way that has not hitherto been possible.
Right. So the interesting thing there is the boundary between the device, there's a thing you have in your hand, and the network actually moves a bit, doesn't it? So effectively you can push more of the technology and more of the processing power into routers which don't have batteries to worry about, right, and have much more ability to be able to process. And so, in fact, you, in a way, are making the phone a bit dumber, but what you're doing is actually making it more seamless. And if you get high connectivity and low latency, all of that becomes possible.
Well, it becomes possible and it enables the broader Internet of Things. I mean, right now, we've been talking about the Internet of Things for, 5 years now? I don't know, at least 5 years, maybe longer. Yeah. And it doesn't do much. Yeah. Right? I mean, there's some toys and some little things. And yes, you can have your lights, you can set your lights to go on before you enter your house, but that's pretty much a toy application. And the problem for the Internet of Things is that, for the most part, it's humans who log into networks. The Internet of Things, those things that are in the networks, have severe security problems right now because they are dumb things that are on networks, and whoever can log into them can control them. Where we'd like to see the Internet of Things go is to have smart things on the Internet. So effectively, things that are users, not just objects on the Internet. So the things are making decisions for themselves. And the classic use case, my own favorite, is autonomous vehicles. Autonomous vehicles will be driving themselves around. And not only will they be driving themselves, they'll be interacting with the power grid. So Australia is talking about getting rid of coal-fired power and moving towards distributed power generation, rooftop solar, this sort of thing, local grids instead of a big national grid or a big, multi-state grids. You can only make that happen if you have real Internet of Things. And my own favorite thing to make that happen is the autonomous electric vehicle, because the autonomous electric vehicle can get a signal from your local grid that power prices are high, please plug in. And the thing can then go plug into the local grid, deliver power to the grid. So, in my own writing on this, I've said that really both electric vehicles and green energy are only possible when they become integrated. Until then, they're both too expensive. Autonomous vehicles, of course, make possible robo-taxi services. So instead of owning a car, you essentially use a robo-Uber, robo-taxi that gets you around. Again, the car, will have to make decisions for itself based on an algorithmic brain. And that starts to become closer to a true Internet of Things, where a thing is not just something you hack into that's on the Internet. The thing is making decisions for itself. Now, what other things will be on the Internet? Honestly, I'm not sure. I'm sure that cars will be. I mean, cars already are, but I'm sure that smart cars will be on the Internet really within this decade. I don't know if you have any other ideas for favorite gadgets you expect to be on the Internet.
Well, I was thinking about the finance sector, right? And the way that money could be moved and transactions and all the other stuff around there. You know, for example, I want a loan. I'm in front of a house. I get all the information there. I can then, use my digital signature. That all goes in, and immediately I get, you can have the loan. You can have it tomorrow.
We may also think of that, if you're talking digital signatures, the first leap of mind is towards blockchain. And here I'm not talking specifically Bitcoin or cryptocurrencies, but blockchain as a database structure.
Yes.
Blockchain is really crucial for the Internet of Things because blockchain has a state of the world determination, essentially, that allows databases to instantly compare with a single number. Do we have the same state of the world between databases? And that's what makes blockchain uniquely suitable for the Internet of Things world. Of course, we need to rapidly calibrate across devices on the Internet of Things. And again, having low latency and having, low latency being the crucial link for calibrating devices in the Internet of Things. But I'm not sure what other things are going to go online. We'll find out as they do. My own instinct is that rather than finance, the key application is going to be for electrical grids. Okay. And the reason is that it's electrical grids that need instantaneous adjustment. We need very quickly to have things reacting to loads on the grid and interacting with each other across the grid if we're going to have small-scale local grids. You just can't have small-scale local grids without having this kind of rapid, artificial intelligence-driven adjustment to power supply and demand considerations. Literally, when a cloud passes over your house, things in your block, in your local network, are going to have to adjust their power use to that cloud. Right? And in order to keep our modern world running, where everything is electrically powered, and they're going to have to have priorities among each other. So your water heater is going to have to know that it's a lower priority than keeping your computer running. So all of these are going to have to interact in a very fast way. And that's where I really see the future of the Internet of Things going. But my guess is as good as yours. We'll really see, we know the technology is going to come. How it's going to be used is a futurist's game.
Well, here's one for you. What about the idea of real-time finance? So rather than having a mortgage with a set company for a long period of time, right? I could actually have an algorithm that continually looks for the best mortgage and switch my finance to the lowest rate, every second or every hour or every day, right? And that whole process just continues all the time. So basically, you completely disaggregate the whole concept of the mortgage, right? And you optimize it, like we're talking about in the power sense, optimize it based on the rates that are currently available, and you have real-time suppliers of mortgages based on the supply demand that they have in their own environment. And so you could rather than have a financial relationship for months or years, you basically quantize it and you basically optimize it. That's all perfectly possible.
Well, you're always so encouraging to me that I feel very ungenerous in pricking the bubble of that. But I think we could do that now, right? You don't need a millisecond response, even a one. If
you try switching your loan,
even 1 second response would be incredly fast, right? So all of that, the barriers to doing that aren't the technical barriers on the level of moving from milliseconds to microseconds.
Right. Okay.
Is really not going to make a difference for that. Now, it might for some, high frequency trading applications for that sort of thing. But for improving the consumer finance market, I don't think this is going to do it.
We could do it already if there was a will to do it. It's just the banks don't want to do it. Fair enough.
Right. Now, the barriers are institutional. They're not technical.
Okay, fair enough. Now, then, before we finish, just one other question. What about the security risks and the security implications of this, right? Because what we're doing is essentially putting more processing closer, more connectivity. Now, can we have the levels of sophistication from a security perspective to be able to make it all work, or will it actually trip us up?
My instinct is that 5G is a step down for security and 6G will be a step up. That is, 5G is just as dumb as 4G, but much more powerful.
Yes,
And
exactly.
that's the problem with 5G. 6G, I suspect, although we're still talking at the level of specifications in theory, no one knows what's going to happen. I suspect 6G will be a step up for security precisely because it will be intelligent, because we'll be programming devices to make decisions that are, I mean, sorry to get into the robots revolution territory, but to make decisions that are in their own best interests.
Yeah.
To try to discern what's a good decision to make and what's a bad decision to make. And of course, we'll get that wrong initially, but I think we'll very quickly learn, and devices will very quickly learn how to protect themselves. I mean, if you think about it now, there have been a lot of these really scary hacks into power generation equipment and massive industrial machinery, because this machinery is online, but the password is admin. Or the password is password. And okay, we're getting better at preventing that, but what we really want is this device to be online and to be thinking for itself, oh, I'm not password protected. How do I know it's really you, Salvatore? What we want is the artificial intelligence being built into these devices, as opposed to being something we use to undermine these devices. Now, of course, once these devices are intelligent, people will find ways to trick them, and security is a never-ending battle. But I do think that 6G is probably going to improve our security. I mean, put it this way: although it's possible theoretically to hack, Google or Amazon's or Microsoft's cloud, it's a whole lot easier to hack my personal computer than it is to hack their cloud. And so, the more we push things into highly professionalized venues, frankly, I think it's probably better for everyone concerned. It's not to say there won't be hacks. It's not to say that there won't be the biggest fails of all once things are more centralized. But I don't think things will really be centralized. What will happen is that the management will be more centralized, but the actual storage of data, the actual processing will be highly decentralized. And as a result, I think the proceeds from any particular hack will not necessarily be as large as they are now.
Very interesting. And the last point I wanted to make was, this is like death knell to the NBN, isn't it?
Well, you tell me. You're the NBN expert. What does this mean for the NBN? I don't know much about the NBN other than that it doesn't work.
Well, bear in mind that many people have fiber not to the premise but to the node, which means they've got old copper wires, which means there's a limit to the latency and limit to the speed that can be done. Now, if they decided to actually re-architect it and essentially put fiber right to every premise, which they should have done in the first place, in my view, that was a stupid political decision taken by Turnbull and Long. I think we'll be regretting that. But even so, it's getting to the point now where if you want to put more and more devolved functionality and smarts closer to the user, as it were, then that's harder to do if you actually got to plug things in all the time, right? Whereas if you've got a virtual environment that essentially is wireless, and you can create the router cloud, and you can create speeds that are just so much faster than what the NBN is capable of offering, then effectively what you've done is you've out-evolved the fiber network. So be interested to see whether the NBN will try to actually, invest to keep current, or whether they'll just say, oh, that was a mistake, and we'll just write it all off. Who knows?
I'm not that kind of engineer, but in a world in which we're even moving to wireless charging, it seems hard for me to believe that we're going to retain wires for data transmission.
Well, not least because, of course, more and more of things that we have will be portable, and we're moving around. And the problem with NBN, I mean, it comes into the premise here, and then I've got Wi-Fi for the devices, but it's all a bit complicated and a bit clunky. And the problem is the speeds are okay for what I'm doing at the moment, but for all the stuff we've been talking about in terms of more real time and lower latency and those things, it's just not up for it. And there's no chance unless they actually make huge future investments. I mean, a lot of investments. And the question is, if they're going to make investments for networks, surely the mobile world that you've articulated so clearly today is where the future's going to be. So I would reckon that we'll be obsoleting the NBN in a few years' time, and we'll move on to mobile. We'll see.
Well, I mean, the real secret to the success of mobile communications is that it's modular, and of course always has been. Cellular, we call them cell phones in the United States. And that means that you don't have to upgrade the entire network to have a working network. I mean, I still get 3G signals sometimes on my phone. I normally get 4G signals. That's great. In the future I'll be getting 5G signals when I upgrade my phone, and fantastic, right? We can have all these technologies working at the same time and put it out bit by bit. We don't have to have an entire network running all at once. We can have the most important applications on the fastest networks. And that modularity of the way wireless is developed, I think, gives it an incredible advantage over big fixed investment projects like the NBN.
Absolutely. Well, it's been a really interesting conversation. Folks, you've heard it here first. 6G is coming. So plan accordingly. Salvatore, thanks very much for your time today. And next time we communicate, we should be doing it at the speed of light.
You got it.
Take care.